finish up here in the next few minutes for me. So on the snow day, we had assigned you guys to either watch the video or look at the PowerPoint or read through or whatever you chose to do there. Section 12.3 on the normal distribution. Today we're going to kind of work through some of these in-class examples, and I'll chat a little bit about some of the details that you would have seen in that video or in the presentation or read about in the book as we kind of go through it, but it's something that I asked you guys to take care of here between, Thursday to today. That was probably pretty realistic given the time frame. So the first question says, in 2012, the mean number of wins for teams in Major League Baseball was 81, with a standard deviation of 11.9 wins. Find and interpret the z-score for each of the following teams, rounded to 3 significant figures. So to do this, you have to remember the z-score formula. What the z-score formula does is it allows you to compare observations that are made under different conditions. So it allows you to correct for in baseball different eras where maybe pitching was stronger then than it is now, or that hitting was better than it was now, or the conditions in the game were different, that they changed some rules. Allows you to compare things across different situations. The other thing that the z-score formula does, it also is a transformation where if you apply that z-score calculation to every value in your normal distribution, it'll convert that normal distribution to a standard normal distribution. But the formula for a z-score is the observation minus the mean divided by the standard deviation. So all I'm going to do is do 95 minus 81 and divide it by 11.9. And that'll give me my value for z, which is 1.18. So there's no unit on that, just as a heads up. What that's saying is that the Yankees' win total was 1.18 standard deviations above the mean, which should make sense if you look at the Yankees won 14 more games than average, and the standard deviation is about 12. So that feels like it makes sense to me. Can somebody try on their calculator to compute the z-score for Part B? The Mets, who won 74 games that season, and tell us what we got. So again, I encourage everybody to kind of be following along on their calculator to practice doing these skills. This will be part of the test, which is coming up in not the too distant future. We still have the activity to do this week, but the test will be beginning of next week. So don't get too comfortable here. That's correct, negative 0.588. And so what we would say then is that the New York Mets won 0.588 standard deviations below the mean. So they were worse kind of than average. How much worse than average? Almost half a or more than half a standard deviation worse than average. Does everybody feel okay there with doing that z-score computation? Let's look at example 2. Now, we're not actually going to do the calculation because in the interest of time, I'd like to hit some more stuff. So we're not going to do every single one of these. But I do want to talk about how you'd want to do this problem. So it says the table below gives the home run totals, the mean number of home runs for the entire Major League Baseball, and standard deviation for the 4 years when the home run record was set in baseball. Which of the players above had the most outstanding performance relative to his peers for his given year? So to answer that question, what are we going to do? The highest one, what do you mean? What's the one? The highest one what? Maren?
The one that's like more standard deviations above the mean.
So you'll compute a z-score for each player. So you'll take their home run total minus the mean number of home runs, divide by the standard deviation, convert each of these home run totals into a z-score, and then using that z-score, we're going to look for the one that is the biggest z-score, which tells you that they were the most standard deviations above the mean. Now, can you look at this and tell which one is going to be the winner? Definitely not. The first one, because if you look, 70 or 60 minus 7.2 is going to be the biggest gap, right? That's the biggest difference between home run total and league average. And then you're dividing it by the smallest standard deviation. So you should have the biggest result there. Is everybody okay with the method that we used here? Again, you would have computed it anyway, so if you couldn't look at the table and tell, that's okay. More z-score, just doing normal stuff. Let's do this. So this asks what proportion of observations in a standard normal distribution are between negative 0.58 and 1.79 standard deviations away from the mean. So to do this problem, you want to start by first identifying the type of distribution that you're working with. In this case, we're told we have a standard normal distribution. So we have z is normal, and because it's a standard normal, you know the mean is 0, and the standard deviation is 1. Okay, that's what standard normal means. When you see standard normal, it tells you the type of normal distribution it is, the two descriptors to classify a normal distribution, the value for the mean and the value for the standard deviation. Okay there? Then what you'd want to do is you'd want to write this as a probability statement. So you want the probability that z is between negative 0.58 and positive 1.79. Is everybody okay there? And now we're going to go to our calculator. Several seconds to refresh, I'm sorry. Where in my calculator do all these distributions live? Second bars, that's correct. And we have two options for normal, right? We have normal CDF and normal PDF. which one are we going to want? How do I know the difference about when I use a PDF versus when I use a CDF? Correct. Correct, if it's an inequality. Which one did we have? We had a CDF, right? Okay. So my lower value was negative something, something, somethings. 5.8, or 0.58, excuse me. So does it matter? So in a normal distribution is for a continuous random variable, right? So things like height or weight, where you can have like any decimal you want, as opposed to like the number of people, which is like a discrete value, or like the number of ways something can happen, which is a discrete value. So remember that this probability is related to like the area under the probability density curve. You guys remember that? If I have a single value on my probability density curve, what's the area under a single value? Nope. Area under the whole curve is 0. Or under the whole curve is 1, Anthony. Remember? So under a single value, it definitely can't be 1. Well, if you say, let's build like a little rectangle, right? Whose height is the value of the curve, and whose width is the width of a point. How wide is a point? There's a geometry question. Who was your geometry teacher? I'm going to go whack them with a sheet of paper. To quote Euclid, a point is that which has no breadth, right? A point occupies no space. Remember? Yes? What is the width of a point then?
0.
0. So the area under a point should be 0. So is that affecting the probability? No. In a continuous distribution, like a normal distribution, there's no difference between a less than or less than or equal to. No difference. In a discrete distribution, like the binomial, there's a big heaping difference. Everybody okay? So good question, Colby. Sorry for my roundabout way of getting there, but I wanted, it was something we would have talked about in the lesson. Okay, so we have upper and lower. It's a standard normal distribution, so the mean and standard deviation are both 1. So there's our answer. The probability is 0.682, rounded to 3 sigmas. It's okay? All right. It says what proportion of observations in a standard normal distribution are more than 1.53 standard deviations above the mean. So again, I know that my distribution is normal 0, 1. And we want more than 1.53. Everybody's okay? All right, so once I have that written, I'm going to go to my graphing calculator. Normal, do I want PDF or CDF? CDF because I'm using a inequality. Okay. The lower on that inequality should be Okay, well, let's think about it this way. Here's my normal curve, right? It's standard normal, so .53 would be here, right? If I want the z's greater than 1.53, which way am I shading? This is the z-axis down here. To the left or to the right? To the right. Okay. So what is the lower value on the z-axis of that shaded region? 1.53. What's the upper value of that shaded region on the z-axis? Positive infinity. Now, can you type positive infinity into your calculator? Yeah, so no, I can't, but I'm just going to use the biggest number that my calculator can hold. So which is 1 times 10 to the 99th. That'll be my proxy for positive infinity. And so I have 0.0630 rounded to 3 sig figs. Does everybody feel okay? What proportions of observations in a standard normal distribution are less than or equal to 0.62 standard deviations below the mean? So less than or equal to what value? Negative 0.62. Because it's below the mean. Try typing that into your calculator and seeing if you get the correct result. Well, if you think about the picture, so you're talking about here and then less than. So what is the upper value there? So negative 0.62 is your upper, right? What's the lower then? Negative infinity. So again, if you're not sure, draw your picture, draw your little normal distribution and label in your means and draw in what you're shading. That really helps if you're having trouble picking what's the upper and lowers. After you do it a couple of times, it'll become second nature, I think. But again, this is the first time you're doing it, so the picture, I think, helps. Colby, are you good? Okay. What portion of observations in a standard normal distribution are within 1.24 standard deviations of the mean? How do I write that probability statement? Are within 1.24 standard deviations of the mean. Aaron?
It needs to be greater than or equal to negative 1.24 and less than or equal to 1.24.
Yeah, so you can write it this way. Note that this is the same thing as we use an absolute value there. You may run across that in the homework or whatever. So an and inequality like that, if it's a less than, is just, oh, and you said less than or equal to, right? Does it matter though? Less than or equal to? Nope. So when we do that, we get 0.785. Correct. Because again, the picture you're drawing here is like that, right? E, let's do E. What proportion of observations in a standard normal distribution are greater than or equal to 0.77 standard deviations away from the mean? So that's definitely one of them, right? But it says away and not above, so where else could it happen? Could be that way also, right? So we write it that way. And what does or mean in probability land? Add. So disappointed. So you do that as two separate computations. Or you could make the following observation. What can we say about these two areas? They are the same area. Why? The shape of the graph of a normal distribution is symmetric. So like it's the same on one side as it is on the other. So you could just do 2 times either one of these computations, and that'll be the answer as well. Not a big time saver there, but it's like still true, right? If you did this one, the upper is infinity. That's this one. Well, you can, I mean, this one could be there also. It doesn't really matter which one is there, right? And this is the same thing as still the same thing. So the other one, the lower would be negative infinity and the upper would be negative 0.77, right? So like, put it that way. Is that okay? You see it? You got it? Maybe? We're working on it. We're approaching getting it. That's good. I'm going to skip through these ones because they're the exact same problem, just they don't have a standard normal distribution. So you'd have to, your mean and standard deviation might change from problem to problem, but like, whoop did it do? All it does is change on the way you know, when you do this, the normal CDF, you have to update the value for mean and standard deviation, but like, not a big deal. Let's see. I want to do, let's do example 8 here. This says if the mean of a normal distribution is 85, determine the standard deviation if we know that a z-score of 0.8 has the value of 93. So what formula are we going to need to use here? Says we have a z-score, right? Probably need the z-score formula. So I have, given the mean, I want the standard deviation. I'm given a z for a specific x. Do I have everything I need here to solve? The formula has 4 inputs. I have 3 numbers and a missing. That should do it, right? So we can just write the equation 0.8 equals 93 minus 85 over sigma. And then you just like multiply both sides by sigma and divide by 0.8 and should be done, right? Is everybody okay with the algebra there? I can just kind of mention what we did. So the key observation there was realizing like that I need to use the z-score formula, which telling you that you have a z-score is usually a good indicator. Okay. What if we change the nature of our problem here a little bit and say, okay, I'm giving you a probability and I want you to recover for me the measurement, the observation. So this is a pure calculator problem. So if you want to recover the measurement from a probability, we're going to be using the inverse norm command. So our area was the 0.335. That's the probability that we were given. The mean and standard deviation were 0 and 1 because it told us this was a standard normal distribution in the problem. And then I just need to decide whether this is a left tail, right tail, or center tail. So if I think about this guy, we have like A here, and because it's less than A, we're going which direction? So we want a left tail. So my value for A should be negative 0.426, rounded to 3 sig figs. How would I do B? Except because it's greater than A. Yep, let me double check my sheet here. 583, yep. Okay, what do I do here? Still inverse norm. Area still here. Still 0, 1. What do I do with this? Yeah. Now notice what happens when you type this into your calculator with the center. Yeah, we get 2 results back, right?
Where's 3, 6?
Okay, well, whatever. Okay, so which one do we want? Do I want the negative or the positive? Nope. So look back at our problem. If I put the negative in here, I'd have the positive number at the bottom and the negative at the top. Is that right? I want the positive value. Right? Over here, though, I want the negative value for A because I need the negative at the bottom and the positive at the top. And right now it's switched, right? So that's the only catch you have to make with that center command, is keeping an eye on that. It looks like we're about out of time. We'll do some more practice on this maybe after the activity on our next class. The activity for next class will be using these normal distributions. And it's about measuring how long you can hold your breath. So if you want to squeeze in some cardio between now and then, so that you feel like you're going to put up a good showing and maybe get over that 60-second mark, I encourage you to do so. Get competitive about it. It's fun. Any swimmers in here?
Yeah.
Okay, let's see you get over 60 then. You should be good at holding your breath as a swimmer. Oh, you can just recycle it. I don't need the equation sheet.
What?